Welcome to a webcast made by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This is part of the Steps into Statistics series and concerns levels of data. This guide identifies the different levels or types of data used in statistics and helps you assign appropriate levels to your own data. Introduction. The basis of statistics is the collection and analysis of information in the form of data. Due to the complexity of the world, data come in many different forms and describe many different things. For example, you could collect information on an individual's height, eye colour and educational level, but can all data be treated in the same way? The answer is no. It is vital that types of data are identified and categorised into appropriate levels. Recognising the levels of data involved in a study affects how the data are presented and also governs choices of descriptive statistics and statistical tests you may wish to employ. For more information about descriptive statistics, you can read the study guides, the mode, measures of central tendency and measurements of spread 1 and 2. According to Stevens, data can be divided into 4 levels, described below, and every data type can be assigned to one of them. However, as areas of research such as psychology advance, the boundary between some levels has become blurred. You may like to think of the division of data levels into those which are scientific measures or counts of some type. Ratio and interval data have meaningful units assigned to them, and those which are not. Ordinal and nominal data. The blurring between levels is seen between some ordinal and interval data types, which sometimes may be assigned to either. You should consult your particular school of study, lecturer or academic literature if you are unsure how to categorise your data. Ratio data. The top level of data is ratio data, and data has a constant ordered scale. Ratio data has a defined zero, and so direct comparisons made between values in terms of ratios have a legitimate meaning. This means that every type of statistical test and descriptive statistic are available to ratio data. Some examples of ratio data are age, height and temperature in Kelvin, capital K. The absolute scale of temperature is the Kelvin scale. In science, 0 Kelvin is the coldest temperature possible. It is known as absolute zero, and so you can say that 10 Kelvin is twice as hot as 5 Kelvin. You can convert Kelvin into the well-known Celsius scale of temperature by subtracting 273, and so 5 Kelvin is the same as minus 268 degrees C, and 10 Kelvin is the same as minus 263 degrees C. It is obvious that minus 263 is not twice minus 268, and so changing scale affects the statements that can be made about data. In fact, the Celsius scale is an interval scale and is explained in more detail in the next section. Interval data. Interval data has a constant ordered scale but has an arbitrary 0 point. Although the difference between values is consistent throughout the scale, the arbitrary 0 means that comparisons between data in terms of ratios are meaningless. Calculations of standard deviations and Pearson correlation coefficients, amongst many others, are possible with this level of data. Examples of interval data are temperatures, measured in Fahrenheit or centigrade, or dates. For temperature, you may hear on a weather forecast that a certain day has a maximum temperature of 20 degrees C and another of 10 degrees C. It seems that one is twice as hot as the other, but it is not. This is because even though there is a temperature of 0 degrees C, it is arbitrarily chosen as the freezing point of water, and so does not indicate the coldest temperature that can be. Ordinal data. When categorising data without meaningful units into groups or sets, if the order of the categorisation is important, then the level of data is ordinal. The most common examples of ordinal data are Likert scales. These are associated with questions which begin, on a scale of 1 to 5. Of course, it does not have to be a scale of 1 to 5. It could easily be a list of ordered phrases such as very unhappy, unhappy, neither happy or unhappy, happy, very happy. Here responses are subjective but ordered. There is thought to be overlap between the ordinal and interval data levels within certain subject areas. However, you should take care when interpreting Likert scale results as pure numbers, in which case they become interval or ratio data. Take advice from your school or lecturer. Another example could be, if you are recording the educational level of participants in a study, the data recorded could be categorised as follows: no education, up to GCSE, up to A level, and so on. Someone educated up to A level is more highly educated than someone with no qualifications. The order of the category is important, and so the data is ordinal. You may label the categories with a number. 1 equals PhD, 2 equals Masters, 3 equals Degree, 4 equals A level, and so on. The numbers associated with each category are not true numbers. Does it make sense to calculate the mean or the standard deviation of educational level? You should use medians, ranges and interquartile ranges for describing ordinal data. Nominal data. When categorising data into groups or sets, if the order of the categorisation is arbitrary, then the level of data is called nominal. In the nominal data level, only the name of the category is important. For example, if you are recording data relating to individuals' eye colour, you may record this data as the actual eye colour, blue, brown, hazel, green, and so on. But you may also label each eye colour with a number. 1 equals blue, 2 equals brown, 3 equals hazel, and so on. Both the numbers given to each category and their order are unimportant, as blue eyes are no more or less important than brown eyes, for instance. So this is nominal data, regardless of whether you use the colours or the numbers. Some other examples of nominal data are gender, breed, place of birth, favourite fruit. Only the mode is an appropriate descriptive statistic for nominal data. Discrete and continuous data. The ratio and interval levels of data are often divided again into measures which can take any value and measures that can only take certain values. If a value can take any value, such as height, weight, and so on, then the data are described as continuous. If a value can only take certain values, such as number of children, count, and so on, then the data are described as discrete. Presenting levels of data. There are a variety of ways of presenting data in charts and graphs. Not all are suitable for each level of data. See table below. You can find out more about charts from the study guides, pie charts, bar charts, box and whisker plots, and histograms. In the following table, OK means you may use this chart type, but there are normally better alternatives. Pie chart. Nominal, yes. Ordinal, yes. Interval ratio, OK. Bar chart. Nominal, yes. Ordinal, yes. Interval ratio, OK. Histogram. Nominal, no. Ordinal, no. Interval ratio, yes. Box plot. Nominal, no. Ordinal, yes. Interval ratio, yes. Line graph. Nominal, no. Ordinal, OK. Interval ratio, yes. Area graph. Nominal, no. Ordinal, OK. Interval ratio, yes. Further guidance and information. If you have any further questions about statistics or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor or make an appointment to see a learning enhancement tutor in the Dean of Students office. Telephone 01603 592761. Email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students Office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills.